Good, good evening, good morning from both sides. I'm Peter, and thank you for joining us today. And for those friends, old and new, let me just give me a couple of minutes to just introduce DAC, the Data Analytics Colloquium, that is sponsored and supported by National Chongqing University in Taiwan and University of Texas at Dallas. So this is our fourth season of this series, and I'm happy to um, I'm happy about this because we have been continuing for 4 years, and that's great. So this colloquium, we try to invite and convince international scholars and data scientists in. So for this online seminars, and for times from time to time we have the workshop kind of seminar webinar. So all the participants of this colloquium can engage in conversation with the speakers and when we have the data available, and we will post it on a GitHub so that we can try to replicate and all the methods that we have learned from this the webinar. So this webinar is co-hosted by myself and Dr. Carl Ho. So we're hoping that you, all the participants, can get a lot of new information about this methods and methodologies from all the speakers. So today we're happy to have Dr. Rebecca Cordell, and then I will pass the microphone to Dr. Carl Ho. He will give you a brief introduction to Dr. Cordell. Carl?
All right, great. Can you all hear me?
Yes.
Okay, great. Um, Good morning and good evening. Thank you. And my name is Carl Ho. I'm the co-host of Data Analytics Colloquium with Professor Peter Pan from NCXU. I'm at UT Dallas. Um, I'm today. I'm really excited and really, I would say that I'm really privileged to have my one of my colleagues and Professor Rebecca Cordell. And Professor Cordell is one of our really popular professors here. So I will talk more about her teaching very soon. And she is Dr. Cordell is assistant professor of political science, and specifically she teaches comparative politics and also international relations courses. Plus, she's recently offering a new course on machine learning of using social text data. And so Dr. Cordell received a PhD from University of Essex and Department of Government. And she later received a prestigious award called the Steve C. Poe Award, the best paper in human rights. And she she's very prolific in her research and also publication. Her publication in many journals, including International Interactions and Human Journal of Conflict Resolution, International Studies Quarterly, and also she's a frequent writer, contributor to Monkey Cage. And Dr. Cordell is highly specialized in machine learning methods using text data. Tonight, she is going to give a talk and also teaches us, and she'll teach us how to use the latest machine learning methods in studying text data, and specifically her project is on repression studies. All right, without further ado, let me introduce Dr. Cordell.
Thank you very much, everyone, for having me. I'm just going to share my screen quickly.
Yes, please.
So do interrupt me at any time if there's any technical issues. Okay, so I'll get started. And so thanks for having me again. Today I'll be presenting my research on machine learning methods, specifically with a focus on text as data and how to classify sentences extracted from annual country human rights reports so that we can assess how states choose which actions when they're engaging in state repression. And the paper that I'm presenting today is co-authored with Kay Chad Clay at the University of Georgia, Christopher Farris at the University of Michigan, Reed Wood at the University of Essex, and Thorin Wright at Arizona State University. So the project that I'm presenting today is called SNARP, and that stands for the Subnational Analysis of Repression Project. This is an NSF-funded project that I joined as a postdoc at Arizona State University, and this is a project where we're continuing to work on how to classify, measure, and explain repression using text as data and machine learning methods, and we're kind of having this meeting right now at a bit of a midway point. So this screen that you're seeing right now is our Harvard Dataverse, where we already have a couple of the data, the replication files published for research that we've already done here. And please, in the future, check back for this at this website to see what we're publishing in terms of our research, peer reviewed, as well as the data, so that you too, if you're interested in state repression, types of political violence and human rights violations, you could use the data as well. So the Subnational Analysis of Repression project was born out of the idea of how can we measure physical integrity rights violations using automated machine learning methods, because this is something that has typically been done in the past, predominantly by humans, by human coding. When we're talking about physical integrity rights violations, this is a subset of human rights violations by countries, and coders would, on big data projects, read human rights reports and then assign a integral interval scale to those countries based on how they felt the human rights were on physical integrity rights specifically, which I'll go over to a bit more detail. And so in this project, we're trying to replicate and automate those human coding processes, but we really want to do that with high levels of accuracy, as well as other model evaluation statistics. We want to try and replicate this human coding process as good as we can. In trying to automate extracting human rights allegations from text as data, annual country human rights reports, and then coding them, the end goal is to be able to explain subnational variation in human rights practices. And this is where our name comes from, SNARP. Subnational being anything lower than the country level, because we know that countries vary in their practices of human rights subnationally, and that repression varies a great deal locally within countries at the various levels, all the way from first order administrative levels right down to very local levels. And so this approach for trying to measure subnational variation of repression is motivated by the idea that most data sets on repression are just at the cross-national level. They're just producing measures for countries over years. And these data sets have been absolutely foundational for the theories that we know about why do countries violate human rights, what explains variation, what are the countries of human rights. But we're really interested in how do subnational factors affect decisions to repress, because we know from a principal agent model of human rights violations that it's governments typically giving orders to state agents, or perhaps even non-state agents sometimes, on pro-government militias, and there's a disaggregated level of chain of command, and there may be variation also within countries, especially those that are federalist countries, where there are different principles and different agents in terms of those countries that are engaging in human rights violations. So having some subnational data would allow us to ask questions like, how does local geography, or how does local state capacity, or specific events that we know happen in just some parts of countries, how does that affect repression? Having this subnational data would allow us to explore subnational variation in repression that we maybe haven't been able to explore on a high level of all countries around the world over really longer periods of time. And in wanting to get to this end goal of producing subnational measures of physical integrity rights, we've broken down this process into automating, trying to make this method as replicable as possible so that others can come along and do this. And we're coding different parts of a human rights allegation, various different aspects. And I'm going to focus on just one of those aspects today. So in terms of that bigger project SNARP, our goal is to have subnationally disaggregated standard-based measures of human rights, respect and repression. And standard-based measures give us a scale where we can compare countries, say from 1 to 5, or whatever scale that is, to be able to say how good are human rights, how bad are human rights, and to compare an ordinal scale that has fixed coding schemes and coding categories to countries that vary a great deal in their types of violations, and even more so when we potentially zoom into countries and see subnationally. And what I'm going to do today is focus on explaining how we code particular types of human rights violations. So in wanting to have this M measure of subnational violations, we also want to be able to say what type of violations. How do disappearances vary at the local level? How do extrajudicial killings vary? How about political imprisonment and arbitrary arrest and torture? Because it would, of course, be interesting to discover that physical integrity rights vary at the local level, but there may be different patterns across different types of violations. And these are the 4 types of physical integrity rights violations that we are coding and classifying using text as data and a supervised machine learning approach that I'll go into a lot more detail today. Our end goal of producing subnational data will be that we are disaggregating human rights violations, specifically physical integrity rights, to the most precise location available so that we can actually assign latitude and longitude coordinates to allegations extracted from annual country human rights reports. But in creating a unit of analysis that will be useful for future researchers, and so that we can test our theories on what explains subnational variation of repression, we're also going to be creating a first order district measure, which is ultimately subnational repression scores in terms of latent variable models and that ordinal scale as well, for first order administrative regions for all countries around the world over long periods of time. But we're going to make sure we have a precision measure in there, because not always is the same level of location going to be available for all violations. And in some instances, there won't be any subnational variation at all. And so while I'm not presenting that today, I'm happy to talk about it more in the Q&A. There's a lot of really interesting methodological questions and problems that we have to solve with this data. We're going to have a global sample of countries from 1999 to today. And the data that I'm presenting to you today and the method and the model is going to be from 1999 to 2016. But as new annual country human rights reports are produced each year describing the state of human rights in every country around the world, we're going to be able to use these models. We're going to be able to run these models, updating them to produce new data each year as they come out. So I've mentioned briefly that we're using a supervised machine learning model, and this means that we've been collecting human-coded data that are examples of what sentences look like when they contain information on physical integrity rights, what sentences look like when they don't. And to collect this data, we had coders coding a huge amount of data for us on a set of pilot countries: Angola, Belarus, India, Mexico, Nigeria, the Philippines and the UK, that vary politically, economically, geographically. But then we also had students code a number of random samples so that we can kind of have these in-depth case studies as well as good coverage over a large period of time in a large number of countries. And when I'm talking about Human Rights Watch reports, State Department reports, annual country reports. This is what I mean when I was mentioning human rights annual country reports. And so this is the text that we use to create the data, the text as data approach. So the machine and human coding approaches that we use in this project is that we've had humans coding these large sets of data, and it was a 6-person team of graduate research assistants and trained interns that were working on segmenting allegations. And then in terms of coding allegations, we've had large teams of up to 40 undergraduate coders, and we've had even more coders joining and coding new data for us as new reports have come out. And it's this human coded data where we're giving really detailed coding guidelines to undergraduate students and saying, when you read a sentence that's extracted from a human rights report, this is what a torture violation looks like. This is what a disappearance violation looks like, an extrajudicial killing violation or arbitrary arrest violation. And we want you to score, is it one of these violations, yes or no, 1 or 0? And we want to then also give them, this is how we want you to code them from, say, 1 to 5, good to bad, etc. And so on. We also will go through today how we have actor coding of saying, is the perpetrator a state actor or a non-state actor? And then we also had students identifying the geo-located aspect of the data itself. We've also developed in this project a dictionary-based approach, whereby we've been building dictionaries that are customized locally by us to physical integrity rights violations. So we've been identifying terms that are to do with torture, extrajudicial killing, disappearances, and arbitrary arrest. And today I'm going to show you an actor dictionary that we've created that helps us to classify which sentences are describing allegations that are perpetrated by the state versus non-state actors. And so part of this approach of digitalizing these reports has been to web scrape these reports, digitalize them, break them down into sentences, pre-process them, create these dictionaries that I'll go into more detail about. And then we use these two approaches of having humans code the data, refining these big document term matrices, which I'll talk about a bit more later, into dictionary relevant terms and common terms in our corpus. And we then use a supervised machine learning method with these sentences that are examples of sentences coded by undergraduate coders and reconciled by graduate coders as torture violations, for example, because we are predicting allegations from that training data that we've had labeled data by humans to train supervised machine learning algorithms that I'll present today to code huge amounts of data, over 2 million sentences, and even more as we're actually moving through this project and we add even more sentences as we go on. So this here just gives you an overview of the approach that we're using, and this here is taken from one of our publications at International Studies Quarterly. We take human rights reports, we break them down into various sentences. We then pre-process the data where we're removing stop words, we remove common terms, we reduce the sparsity to less than 99%, to greater than 99% rather, and we reduce the sentences to lowercase. We then engage in tokenization based on our dictionaries of terms that are relevant to physical integrity rights. We create a document term matrix, which is a matrix whereby we have sentences as rows in our data set, in our data frames, the columns as terms, and the values in that interaction between the rows and the columns are a count of words and the word count in terms in our data sets. So what this then leads to, once we've engaged in this sentence pre-processing, we've digitalized all this data, cleaned it and structured it, we're then feeding in our human training coding, running some supervised machine learning algorithms holding out samples that we can test on. We're making predictions based on whether sentences in the data are actually a physical integrity rights violation or not. If they're not, we discard those and we proceed forward with the final allegation data set of physical integrity rights sentences for all countries around the world from 1999 to 2016. So this is based on a probability model, and we also have binary classifications too. So what I'm going to do today is provide a lot more detail into one specific process that we're working on right now in this broader, larger project. So what we're doing right now is we're comparing state repressive actions. We're classifying the content of physical integrity rights abuse allegations using machine learning methods so that we can try and answer the question, why do states favour some form of repressive action over others? Why do states choose to engage in torture or arbitrary arrests or disappearances and extrajudicial killings? That can lead to some interesting substitution questions, as well as looking at how all of those violations and the choice to engage in those violations interact with each other as well. But for the purpose of today, I'm going to be going into the methods and the data science perspective of this. And so the research question that you can be thinking about right now that we're trying to tackle with this paper is, can we automate and replicate the human coding process of identifying state-based physical integrity rights violations from annual country human rights reports? And specifically, can we code the type of violation and the actor? So the motivation of this research paper is that annual standard-based scores on country-level repression rely on human coders to code information on abuses, and it's a tremendous data endeavour that they've engaged in that we're trying to build upon here. However, these measures do not leverage the detail in reports. So often these sentences and the information contained in reports tells us so much more than just did a country abuse human rights, how did they abuse them, and to what scale. But we can actually find out who's abusing, who's the principals, who's the perpetrators, who did what to whom and where. So the what is the type of violation, the whom is the victim, and the where is the subnational location aspect, which we're going to be working on later in the future. So what we're trying to do is really leverage the amount of information in here and say that these sentence level allegations that we've already been extracting and building from these human rights reports are the key building blocks to existing variables, and that when human coders are reading these reports, these lengthy reports, and assigning scores to countries based on their human rights protections, that actually we can break down these steps and try and look at this and explain why, and actually leverage this variation, that certain terms may be related to these codings and certain in-joint violations of certain violations as well. However, these really impressive hand coding projects like the Political Terror Scale, the Syria Human Rights Project as well, it's very costly to code these reports every single time they come out, but especially at the sentence level. So that's why we're automating it. But we don't just want to automate it to speed things up. We need to make sure that we're also producing models and methods that are highly accurate and have good model measures outcomes, and we want to leverage this information within there. So the human rights reports that we start with, this is the qualitative data, and text-as data approaches is about turning qualitative data into quantitative data. And so these are the types of reports that we use. We use Human Rights Watch, Amnesty International, and US State Department to digitalize those reports. We extract them, we break them down into sentences, because typically a sentence describing a human rights allegation is at the sentence level or multiple that we can break it down here. This is just one example. This is Angola's 2004 State Department report. And just read this sentence. There were reports that military forces in Cabinda, including insurgency forces, executed civilians. The Human Rights Report on Cabinda, published by the Civic Association in Mapalanda, alleged that there were 19 civilians killed by military forces from September 2003 to December. So looking just at the bold aspects, we've got so much information that we could leverage by using this text as data approach. We can identify a violation type, that there's an extrajudicial killing took place. We can identify the actor, that it's a state actor, and precisely we can say that it's state military forces and insurgent forces that engaged in this violation. We can also identify the location, the Cabinda province, which will help us get to the subnational aspect later along. And we can even say how many people were affected. What was the scope and extent? It was 19 civilians, and it was the victims that were civilians. And there's even more information in there that we're not looking at, like you could actually say the particular month that it's happening in. What I'm going to do today is focus just on these two variables. I'm going to show you how we right now are automating and classifying sentences based on the type of violation and the actor type, the state. So in our machine coding of violations, we are taking these 2 million sentences that we have, that we've created and extracted from all of these country human rights reports for all countries in the world from 1999 to 2016. And we're trying to code sentences based on, are they a disappearance, an extrajudicial killing, a torture violation, political imprisonment, or arbitrary arrest and detainment? And then second, who's responsible for the violation? And we're just creating simple binary variables here. Is it a disappearance, killing, torture, arbitrary arrest? And is it a state actor, yes or no? That's what we're interested in. And predominantly, we're interested in identifying whether these are state actor violations, but there may be people out there that are interested in the non-state actor violations, which is why we've added this variable in. So we have 196 countries in total with these 2 million sentences that we're coding, of which some of these sentences contain information on human rights, some of them don't. Some of the sentences are very general descriptions of human rights situations. Some are very specific. The method that we're using to classify the type of violation as well as the actor responsible is a supervised machine learning approach. Specifically, we're using repeated k-fold cross-validation, which we're repeating 5 times on 5 k-folds, which I can explain a bit more later. But basically, it would take training data, split it into 5. Each time it trains, pull one of those folds out, pull another one out, run it again, and then would take the average and give the average accuracy as well as model evaluation statistics later on for that process. It gives us better model fit for our accuracies as well as other model statistics. So we're feeding into these supervised machine learning models human coded data, where our undergraduate students have coded sentences extracted from these human rights reports based on type of violation and is it a state actor, yes or no. And then graduate students have come along and reconciled that data for us. And that human coded data we're turning into document term matrices, whereby what we're feeding into the data set is a data frame for the machine learning variables, which is the columns are terms in the data, the rows are sentences, counts of the terms in each sentence, and then a target variable of did our human coders say the sentence was a physical integrity rights violation, yes or no. We're using this training data to train the model to make predictions on much larger sample of those 2 million sentences, and we're holding out test data so we can actually measure how well is the machine doing. Is it doing as well as humans or not? The variables that we're creating here are binary classifications of these violation types, as well as the actor type. And we're also creating probabilities so that future researchers or future users of this data set can actually increase or decrease the thresholds of probability for, is it a disappearance, is it a torture violation? And something we're really interested in doing as well later is looking at the joint probabilities of this type. How does that affect things as well? Lots of information around to play with. So the training data that we're giving our supervised machine learning model to try and automate coding physical integrity rights allegations by violation type and state actor is 14,000 human coded sentences in total, which represents 80% of the data that we have coded. So when training supervised machine learning models, we want to make sure that the majority of the data is going into training the model so that the model can identify patterns between the word count and co-occurrence of words and the classification of that sentence. Is it a physical integrity rights violation, yes or no? What type? Or is it a state actor? So the training data that we're giving it covers 6 pilot countries: Angola, Belarus, Mexico, Nigeria, Philippines, and the UK, for odd years in that period. And then a random sample for all countries in the world from 1999 to 2016. So we can have really detailed examples for certain countries, and then we can have a good coverage for all different types of countries around the world as well. So when we're giving this 80% of training data examples of word counts and examples of sentences that are physical integrity rights violations, yes or no, we're then holding out test data, because the way that we can evaluate these supervised machine learning models is to compare at the end how many of our allegations are having correct overlap with the machine and the human coded perspective. And there's lots of different ways we look at these model evaluation statistics as well. So this is about 6,000 human coded sentences that we leave out. And the sentences that we're ultimately going to test our model on to be able to say how well do we replicate this human coding process. It's 20% of that training data, all of the data that the humans were creating for us, plus out of sample for just one country, India, odd years from 1999 to 2016, so that we can say how well is our model for predicting one country that it's never seen, what it looks like in the training, and detail for just one country. And then our out of sample, the second test, is a random sample. How good is our model for coverage over all different types of state repressive behaviour potentially? I'm really happy to talk more about the methods that we're using in the Q&A, but here are some of the results. So these are the results just for accuracy. In the following slides, I'm going to present accuracy statistics, but we have lots of other different model evaluation statistics in the appendix that I can show you. So what this shows you here is for those in-sample sentences that we held out 20% of the training data, how well do our supervised machine learning algorithms on the left, support vector machine, naive Bayes, logistic regression, and a random forest model, how well do they predict that the human coded sentence classifications in that test data? And so you can see from here that those top 4 are individual supervised machine learning algorithms are actually performing quite well, although there's some interesting variation. So disappearances seems to be the highest here, over 90% accuracy on some of those algorithms. Kill, slightly less performance, about 80% accuracy roughly. Torture is where there's most variation in terms of our machine learning models accurately predicting the classifications of sentences that are humans coded in the test data, not doing as well, and imprisonment doing in between. As well as testing how well do these supervised machine learning algorithms predict the classifications that humans give sentences for this test data on these variables, we also do a majority vote, which rather than just relying on one of these algorithms actually takes the best of the majority predictions when they all agree at the same time. And I'll introduce to you a bit later why we do this, but we just use 3 algorithms. We only use the support vector machine, the logistic regression, and the random forest as our majority vote. When 2 agree, we use that. We don't focus on naive Bayes, and that's because, as I'll explain a bit later, it's when we look into it, the naive Bayes is actually not doing very well at all what we want it to. So our out of sample test data looks just at India, and what we find is that our supervised machine learning algorithms are doing quite well on also predicting just one particular country, and it never saw India data. It wasn't trained on any India data. Again, similar patterns though, disappearances being the highest accuracy prediction, torture being the lowest. We also then test on a random sample of sentences, and we again find quite high levels of accuracy here, similar patterns. Disappearances are top with kill. Torture is doing better for a random sample here, and imprisonment doing well as well. So we have kind of a good coverage potentially, but we can definitely break it down in the Q&A into some of the other model statistics which tell us more detail. This is what it looks like, because we're taking these automated machine coding sentences and creating measures. We're creating a measure, for example, all disappearance allegations. So this here shows you all of the human rights reports, the Amnesty International, the State Department, the Human Rights Watch reports. We're aggregating all countries' number of allegations over this period of time. Countries that are shaded dark are those that have the greatest number of disappearance allegations, and those that are shaded light have the least number. So we see that China has a lot of allegations here, so does Colombia, as just a couple of examples on enforced disappearances. This is from our machine-coded variable. For extrajudicial killings, it looks a bit different. And so when we aggregate all counts of allegations that our model identifies from those human rights reports, for killings, we again do have Colombia being high, but we also, in addition to China, have India scoring high, as well as Pakistan as an example. For allegations of torture, China really stands out here. So China by far has a great number of allegations according to torture, according to our model. Russia, India again. And we can talk a lot more about how we're going to scale these variables, because these are just the raw counts right now. Again, political prisoners. China stands out here a great deal as well for having the greatest number of allegation counts for political prisoners. And one thing we can talk about as well in the Q&A is how this looks different when we potentially in the future will break down by report type as well. So another way in which we want to validate our models is by comparing our models, our count of allegation sentences by type, to pre-existing measures on physical integrity rights allegations. So in these axes here, we have on the y-axis the political terror scale scores that countries are given by human coders. On the x-axis, we have the number of our allegation sentences. And we indeed find that we do have correlations between our variables. And so you can imagine more number of violations also are tallying up with the number of scores that these countries are getting, and we're finding good patterns there. Countries that have no allegations have a lower score. Countries that have a large number of allegations have a higher score, which is what we would expect. Same for extrajudicial killings. We have overlap between pre-existing human-coded data from the political terror scale on this type of violation is correlated with our data counts. Similar with torture. And obviously variation across some of these measures, but we're seeing patterns that we would want to see, that there's correlations here between these measures, which helps us externally validate. Because the cross-validation that we were doing in terms of comparing the accuracy of how many does our machine learning model on average get accurate and get right to the human coded sentences, this is taking then the comparison externally to other data that exists out there. So what I've presented so far is how we classify the type of violations, but I mentioned that we're also interested in identifying who the actor is. And so to do this, we've come up with a state actor dictionary whereby our human coders encoding all of that and collecting all of that data were also identifying who the precise actor was, the agent in particular that was engaging in the violations. And we created a document term matrix for a list that our coders had created of state actors that engage in violations. We then went with the top terms and then reduced the data of sentences that contained those terms to relevant terms here related to actually state actor violations. So this is a state actor dictionary that we've created here. So what we do is, in a very similar way to how we coded the data, we're feeding the document term matrix, which contains these terms on actor and the sentences, and it says this is a state actor that perpetrated it, it isn't, 1 or 0. So we've got the target variable there, and we've got the term word count there for every sentence that we're training on. And these are the results. So if we compare the sentences from the human rights reports that were coded by humans, for the in sample, we get the state actor identity correct for that 20% in sample sentences, as well as the out of sample data for India and the random sample as well across these different countries all around the world for actor type. However, you'll notice something, it's not as good as some of the type violation models, and we're working on ways to refine this right now and think about it. So we want to go even a step further and do another application, because something that I teach my students a lot is validation is critical. And so we always want to validate our machine learning models because we're automating them, but we want to know how well are we doing. So we've internally validated it, we've externally validated it, and now we just want to test a simple theory. Something that we know about the world is that in the wake of the war on terror after 9/11, the US led the CIA rendition, detention and interrogation program, which was aimed at interrogating individuals that were suspected of engaging in terror after the 9/11 terror attacks. Individuals were kidnapped, detained, put into secret planes, transported to secret detention sites and interrogated. And we wanted to ask ourselves a question as to whether countries around the world that cooperated with the CIA, over a quarter of the world's countries, this was a system that international cooperation in these human rights violations was critical. Is it the case that our model identifies more physical integrity rights violations for those countries than non-cooperating states in the period that this rendition system participated in? Because there's an interesting theory there about alliances, about diffusion of behavior, and about what we would expect is an increase in physical integrity rights potentially in those countries that cooperated in this system that involved torture around the world. So we just do a really simple t-test, which is we just compare the number of our physical integrity rights allegations for countries in our sample that engaged in the rendition, detention, and interrogation program and those that didn't. And what we find is that, yes, the data that our automated method produced here does suggest that the mean number of allegations was 112 for that period for countries that cooperated compared to 87, and that difference is statistically significant. So to take away here, countries that engaged in the CIA rendition program, it seems, according to the allegations in our data sets, may have potentially engaged in more violations than those countries that didn't. So let me just wrap up here. What I've spoken about today is how to do some machine coding of sentences extracted from human rights reports by violation type and state actor. The results suggest that we can replicate the human coding process with high degrees of accuracy, although there's some variation over our models. What this does is reduces the time needed to code the information from human rights reports, and also we're just doing it in a very transparent and reproducible way. We already have people using our data that we've already produced to go out there and code new types of human rights violations, new types of information there. And we're going to be able to easily update our data as new reports are released each year. That will ultimately be able to help scholars of repression investigate new questions at a much finer grained level of detail. So as far as next steps, we've coded on violation type, who the state actor is. We're now going to be disaggregating this type measures by reporting source, because it'll be very interesting to see how Amnesty International talks about torture, how US State Department and Human Rights Watch. And importantly, that is also what the pre-existing human rights data projects do, like the political terror scale, break it down into source. We're also going to compare our other actor dictionaries to ones that already exist out there, like Cameo and the UCDP data set, to see maybe adding them to our models, as well as comparing them. Then after this paper, which we're hopefully sending out for review very soon, we're moving next on to measuring subnational levels of repression, whereby we are creating a latent variable model that can capture variation in the state behaviour on repression. And we're presenting this next week at Peace Science Conference. And then finally, we're going to be producing this repression data that allows us to get at the subnational determinants of physical integrity rights abuse, geolocated data. And so what we hope to have at the end with this geolocated data is to be able to zoom into any country in the world and be able to say, how is the human rights varying subnationally? So this is what we hope to have at the end. This is an example, 1999 US State Department report for Nigeria, whereby we coded and assigned scores to countries on the intensity. Dark shaded are widespread physical integrity rights violations. Light shaded is no physical integrity rights violations. And if we kind of compare another year, we see a lot of variation here. And so we're going to be able to hopefully test theories about, in, say, the case of Nigeria, the presence of Boko Haram in some areas, what's the difference between urban, rural areas, etc., and so on. So I'll stop there. Really look forward to any of your questions on the data, the method, or the broader project. Check out our Harvard Dataverse, and I'll turn it over to all of you now. Thank you.
All right, great. Can you all hear me? Okay, good. I think we will just go through a round of questions and answers, and usually I would just get started with some questions and then wait for the audience to hit up, and then wait for the more questions from Taiwan side too. And now, Rebecca, can you? Now, I think this is a lot of technical procedures that you're doing, and can you briefly talk about what kind of environment, what kind of packages, and what kind of software platform you're focusing on?
Yeah, definitely. So, predominantly here working in R Studio and working in R, and for the I can walk you through the whole process actually. So first step was web scraping these human rights reports from the internet. And to do that, you can use Python, but in my class, I teach students how to do this using R. So to mass bulk download reports from the internet, then in R, break them down, segment those into sentences. And this would be through natural language processing, then pre-processing. And so for text as data approaches, the pre-processing aspect that we use often is packages like TM, Quantida. You can definitely check out my replication materials that are on the SNARP Harvard Dataverse, because there will tell you the specific packages we use. But they're the types of packages we use to pre-process the data, to then create document term matrices containing the word counts, the target variables. As far as the supervised machine learning goes, in our studio, still using Carrot as a as a machine learning model, and this is a brilliant CARET. This is a brilliant package, because it has so many algorithms. And so I just presented to you today 4 algorithms that we explored, but there are many more algorithms there that are out there as well. And so that's something that I definitely encourage you to think about. That's where we do the cross-validation as well, and as well as creating our dictionaries in R.
Yes, seems like you're teaching actually 2 classes. One is machine learning class. The other one is like a text mining and the text processing class. And you're combining these 2 groups of methods in one class. Now, for students to start, for example, Taiwan students, or maybe some other students coming from other social sciences, or not necessarily computer science. So how would you suggest you to start and for doing, number 1, machine learning models, number 2, text models, or modeling using text data? Because text data itself, and you also involve a process called web scraping. And so that will be something for our students to get to understand how to start. And how do you proceed of about this? And I mean, do you take one thing first and then you do it progressively?
This is a great question. So one thing that I always recommend my students to do is to look at DataCamp. On DataCamp, there's text as data courses that you can take that are really good at providing you foundations. And so what I'm really talking about mostly in my class right now is predominantly focused more around text as data approaches, how to extract data, how to describe data, how to clean that text as data, then how to analyze it. And so I present certainly some machine learning models, but it's more the text as data methods and courses that would help you to work through this. But the way I recommend students to approach this would firstly be to look at, first you need to get your data in any research design for text as data projects. So you need to get the text first, and often that is about the web scraping, or you know, downloading those reports or newspaper articles, or downloading some tweets. So that's that first step, extracting data, then the pre-processing step, then the analysis step. And some of the methods that I look at in my classes, today I presented to you supervised machine learning methods, but we also look at unsupervised machine learning methods like structural topic modeling. Today we were looking at word embeddings as well. And there's a course, certainly a class at the end, that focuses a lot on replication and validation, because it's just, if not more important, to actually validate and, you know, really investigate how your model's doing, and make sure that they're reproducible, so that other people can come along and replicate these processes that we're developing and adjust them and modify them themselves. So I definitely say start with R, Another really good textbook that I can recommend to everyone is called Text as Data.
Yeah.
This is a great project and book. It's a brand new one that's come out recently, and it's very in-depth. That will get you off to a great start.
Yeah, great. I have many questions. Maybe I should let the Taiwan side to pose some questions first. Peter, go ahead, please.
Yeah, sure. Well, thank you for bringing it up first, because actually some of our students here are at the novel level in the machine learning. So the question is that the project that you just introduced, this unsupervised machine learning method. So
supervised.
Supervised. Yeah.
Supervised. I'm sorry, supervised. So which requires more, labor-intensive human coding process. So can you share with the audience about why you didn't opt for reinforcement learning or even supervised learning? I'm asking the question because more specifically, when using text as data, and then what advice would you have or give the students in considering the methods and the research questions, the match to be answered? Sometimes we have to choose, is this more appropriate or suitable for supervised machine learning or unsupervised machine learning? Just give us a picture of that.
Yeah, definitely. So I think in general, I'll describe why we use supervised machine learning methods. So our idea is that the amount of expertise that is required to code these physical integrity rights allegations, students for decades have been trained on these human rights data projects, the political terror scale and the Syria human rights data, of how to do this. And so it's the idea that we're creating categories and scores that need a great deal of kind of knowledge and information, and so we need to curate that data. So a reason why we're choosing supervised machine learning and customizing our data and feeding that into the machine learning model rather than using an unsupervised model where we don't tell it anything about this is what torture is or this is what extrajudicial killing is because even the term torture is incredibly tricky. Torture is something that is very multifaceted. It's something that has changed in how it's reported over time, what's classified as torture, psychological torture, physical torture. And so the reason why we've created this supervised machine learning approach was that we felt that this data here and the actual task at hand is very specific, very specific to the knowledge. And so we needed to feed in customized data. Also, we really just didn't want to take out the human process here. And so the reason why these big data projects like political terror scale, Syria human rights scale have been so important is because of the human coding process aspect here. And so we wanted to use machine learning models to supplement this process, whereby we use humans at the beginning and the end to validate and train our models. But for students that are thinking and questioning themselves what types of methods to use, I always tell my students it's just down to the particular research question. So, what is your research question? If your research question is something like, what are newspapers on the left and what are newspapers on the right of the political spectrum talking about when they mention Democrats or Republicans or the economy or other things? Well, maybe you could use a structural topic model for that to identify the topics in two different corpuses from a left news organization, a right news organization. And so that's unsupervised, and maybe we don't necessarily need to curate and feed in this data, but we can actually just let the model run, see what it discovers, but then validate it at the end. I've had a lot of students though also using dictionary-based methods. So sometimes, since this is more of a text as data approach class than a machine learning one necessarily, just doing word counts can be interesting. Take a one of these human rights reports. How often does the term torture co-occur with the term conflict? because that could tell us about the relationship between conflict and torture. That's just a really simple, what's the word count? So I think deciding on the method is all about what's your research question. And also something I think you pointed towards was it's a lot of effort and time consuming to create this, human coded data. But not all projects need to be this big. And there's also off-the-shelf dictionaries. There's off-the-shelf data that's already out there that is, showing that perhaps we don't actually need this supervised machine learning approaches as well. But I tell my students in their class, in their projects, also create some data yourself and get one of your friends to do it and have that as your training data, see what happens, and then compare at the end.
Okay. Yep. Thank you. Thank you.
All right. More questions, please. Now, I'm really interested in human rights data, and I think when I did some research, I think almost 10 years ago, most of the data are human coded, and so I still remember days we need to get the human rights report in the paper and then read it, and then we have to code it, and we have multiple coders, and then sometimes you do not know which coder is actually browsing it, or this is a quick glance, and then they may make up a number, and so we have to check the compra alpha to check if that could be some coders problem or intercoder reliability, etc. Nowadays, so you still like to use the human coder and as a gold standard, and then maybe in future you can try some more machine learning models, or maybe now generally more like a language models. Do you think it's still we can fully count on these machine based models and to replace human coding? What do you think? Or in the future, would that happen?
So I think one thing we're committed to is having combining both the strengths of humans and the machine here. And so one thing that we want is to be able to have the human coding process here as well as the machine coding process. But one thing that I'm sure, we'll just be interested in exploring, because it's just an interesting methodological question as well as is, does an unsupervised machine learning model perform just as well? That'll be something interesting to think about. But the process that we actually went through to create this human coding data, you've identified some issues that we encounter often with human coded data, and we kind of tried to really create a big mechanism here whereby students are being trained, they're in weekly meetings, they're coding multiple coders, the same sentences, they're having discussions about how to code this sentence, that sentence. Then if there's a disagreement, they discuss it, and then, separately, but and it working independently, and then have a graduate student coder come in to try and reconcile and talk about it as well. And so we have also done intercoder reliability tests, which is something as well, because we're taking the approach here that human coded data is the gold standard. In an ideal world, we would have humans just code all the data. It would take too long. But we need to make sure that that human coded data is actually good enough. And so from that perspective, we have intercoder reliability tests where we can test the reliability between coders to ensure that the data we're giving the model is good. Because if you give it bad data, then it's going to be a bad model.
Yeah. So would these, can you give some examples how we can apply these methods in other political science or social science or policy science research? So such as we encounter a lot of text data, a lot of reports, and for example, how do you evaluate the green practices of different governments? And do you think we can apply this kind of methods too? And I'm eager to learn, and some standards or maybe some SOPs we can follow, and then we can use these set of research routines applied to other disciplines and other research projects.
Yeah, definitely. So I'll take some examples from the class I'm teaching at the moment. And so I'm teaching social scientists. And so there are criminologists in the room. There are public administration people, sociologists, but a lot of data science students. And so these methods can be really applied to any topic, any type of text. It's then just going to depend on what's your research question. So perhaps some examples is have a student that is working on creating a measure of crime in the United States as just one example. And so they're looking at crime reports, they're doing word counts and creating dictionaries for different types of crime so that they can create measures that could potentially be proxy for the levels of crime within a country. And those reports are annual reports. Have another student that's working on New York Times articles, has used LexisNexis, and LexisNexis is another way to get data, because that's text, newspapers, reports. And they are using these newspaper reports to look at how the Supreme Court is discussed in New York Times articles before Roe versus Wade fell and after. Have another student that's looking at actually creating their own ChatGPT, basically. So we were talking today in class. We were talking today in class about word embeddings, and the approach that we use for this project that I presented is called a bag of words approach, which is where we don't really care what order the word torture appears or where it appears, but rather the fact that it appears we think means something about torture in that country in that year. So word embeddings takes a much more deeper approach to the meaning of words, the co-occurrence of words, the relationships between words, which is actually the foundation for now generative AI and many of the models that we're using. Text analysis and text as data is also, word embeddings is behind auto type on Google, you know, so we use it in our daily lives all the time when we're messaging, when we're texting, writing an email, and it predicts the words that are going to come next.
Yeah, and it looks like there's no limit, because everywhere that you have text data. And I'm sure the next question could be coming from Taiwan. Hey, and could we apply this to other languages like the Chinese languages and text, and particularly, and I used most of data coming from the English, of course, so it's easy. So how much do you know about things could be done in other languages, and using this method, the general methodology? Yeah.
It's a very good question. So traditionally, research and data using text analysis has been biased towards the English language. And so think about that. That has big implications for research. If most of the text and most of the data and most of our theories are tested on just English language sources, then we're missing out on a huge number of different variations in the types of social science topics and events that we're interested in. Fortunately, though, things have really improved recently, and researchers have been showing that these types of models can perform well on non-English language different approaches. And so it's all going to depend, again, looking into the types of packages in R, as well as the types of modules and programs that can be used in Python. But yeah, typically, traditionally, the approach has been to maybe translate non-English into English to analyze it, but we're getting much better these days now with non-English language speaking modules as well.
Yeah. Peter?
Yeah, I'm just a follow up because like Carl just said, we can use this in different topics, public administration or other disciplines. And text mining. One of our students asked about public opinion. Okay, text mining, public opinion. And some students, even some survey service companies, they largely use sentiment analysis and things like that, and they use it as a quick fix. But actually, as you just mentioned, that the human coding is very important in terms of explaining or try to find out the causal the relationship, or there's some different connotation of a word or something like that, different notions. And then, but nowadays we see a lot of quick fix things, and then you just plug in and then use the algorithm and see this is the answer, and then that's not I don't think that's a good way to go, because like you said, we have the human process, we have the machine process, and so that we can come up with a more reliable and the valid answer of that. So can you just share a little bit about with the students that, because there is a impression that you can just go and then see, for example, you want to have a word cloud, so they think this is easy. You just put in some website and then you generate a word cloud. So this is easy, but it doesn't mean anything. Not anything. Just it means just superficial on the surface. But if we want to dig into the real meaning behind this, and then we have to spend or invest more time and like human coding is a part of it. So just give us a general comments about that.
Yeah, sure. So I think one of the biggest motivations and perhaps the most intuitive answers here as to, why do we include humans? Why are humans important? Why don't we just automate everything AI? Is that language is inherently complicated. And when we're reading a book or a journal article, we're taking the context, we're reading between the lines, we're getting meaning. The models that we're running, on document term matrices are turning those words into ones and zeros, and we aren't able to capture the meaning as well. And so I think that is one reason potentially to, still think about the human process there, and why the gold standard is human coded data. And, research has shown that obviously generative AI like ChatGPT is, very impressive, but it doesn't always give you the right factual answers, and there can be misinformation and citation issues. And
Yeah, indeed.
so that is something I think to think about.
Yeah, and I'm doing something similar, like in that direction, using text data, and but one thing that I found out, there is still a lot of variability when you count on the language models and such as ChatGPT, and Dr. Cordell clearly pointed out, particularly when you want to do some citations, and ChatGPT citations are not reliable at all, and that if you put it in your reference list, you'll get into trouble. And how would you predict in future, and this kind of language models and or text models could help us improve our research in what direction? And I'm thinking, and at one point I believed that, I can count on ChatGPT to do the literature review, but found out this is not a good choice. Then another way of doing that, of course, is to help you improve your codes and coding. So how much do you think that generally these text models or language models can help us in research, and or what areas that we need to be more more careful, what kind of caveat we have to take? Yeah.
I think that we're going to see a lot more of generative AI being used in research, and I've been to conferences lately where researchers are using actually ChatGPT to code things. So, you know, we had human coders coding our sentences, but that's something that, you know, students could explore if they don't have as many resources. How good is ChatGPT at coding, you know, things on particular topics related to social science? It's a text model, and so presumably it may do quite well, actually. And so that'll be something that's interesting, although some of the reports at the conference were that it wasn't doing as well as expected. And it just depends on what the topic is. How complex is a topic? How complex is the language that you're using? But yeah, certainly to students, I would definitely say that there's lots of opportunities for using text as data approaches to answer social science research questions. And it doesn't always have to be causal, and often it's actually just more correlational questions, and it's just about identifying patterns. How does one topic relate to another? What's the relationship between, you know, how does the concept of democracy, what words are often used when describing democracy in newspaper reports in countries that are allied with the US that versus that aren't? You know, there's just a lot of patterns, questions here that can be answered with text.
Yeah, and looks like this is really a big trend and a great opportunity for us to have new data, new research methods, and there are a lot of things that we can learn. And actually, the week after next, and Professor Ryan Kennedy at University of Houston, he will give us a talks in similar topics like using combined intelligence, and which is like a algorithm or machine-based method with the human-based method too, and methods too. This will be something really, really interesting. I think, and your research is exactly that. This exemplary, combining human coding and machine coding to improve and to get better. And I have a question now from the audience, and let me read it out. And I understand what counts as one incident of human rights violations is based on the reports. However, given that there may be discrepancies in reporting, just take the Angola Cabinda's example. I think reports in another country may choose to report multiple violations at various locations instead of one general statement of one violation that spans over months. Yeah, that good question about aggregation. And how can we ensure the unit of analysis, which is each allegation, are homogeneous, especially in terms of measuring intensity? Okay, I think,
Yeah, this is a really good question. Thanks, Kelvin. So really there's a lot of really interesting problems that we have to deal with this project. And so you can imagine a scenario as well, more generally, that I think gets at the subnational aspect, whereby you could have a first order administrative region in a country that has no allegations of physical integrity rights. That could either mean physical integrity rights are great there, no one's torturing, killing, arresting, or disappearing anyone. Or it could mean that there's actually observational issues at play. Maybe the best violators are so good at it that we never find out, that they silence people, they intimidate people more. Maybe there's not press freedom in those places, whereby we don't have journalists or human rights actors in those, say, more rural regions that are reporting on these sorts of things. So there's a lot of issues there that we're going to be dealing with and tackling with in the next stage of the project. Also, there are sentences that will describe the location specifically, like there were reports of torture at this prison in Syria, or there were reports of extrajudicial killings in the north of Afghanistan. Well, where's the north? What are we going to code in the north? And so we've talked a lot about using centroids, definitely having precision for those estimates when there is a very general geographical summary given as opposed to more specific. And this is actually a kind of very conceptual question, a philosophical question that we're going to have to, you know, we'll work through and identify different approaches here. And it's something that we talk about a lot. So while this is actually the final step, the subnational approach, and we're going to be using a ton of different approaches to see what best. We'll be using baselines from previous years because of the idea that what predicts best future human rights violations is going to be human rights violations right now, that temporal dependence. But I think that the interesting thing that this question addresses is, say there's a sentence that names 3 or 4 locations that are within the same first order administrative unit. So when we get to this stage of coding the data, it would identify 3 different places. But one really easy way that we could deal with this is say that in the same, if it's the same sentence and the same type of violation, then we only count it once so that we're not overcounting. I think that would be a way to do it. Ensure that's where having all of these variables that we're working on now, like type, actor, when there's a unique combination, unique one of these violation type, actor in the sentence, and if there's more than one location identified, then we don't count it more than once. But to just open up even more interesting challenges that we face, there's also you know, the issue that reports will, the US State Department report will maybe report on the same violation that Amnesty does. And so we'll be working through how to ensure that duplicate allegations aren't addressed, certainly ensuring that we only count the same allegation once if it's in multiple reports, therefore multiple instances in our data set. I think that's where having the individual unique human rights source scores is going to be important as well. But then aggregating up in terms of intensity, I think that's where dealing with that overcounting at the disaggregated level, because we're disaggregating and then working back up, is where we can deal with that, so that when we're saying intensity, things are worse in one area or one country than the other, which we may use just averages, average word count, say, just as an idea to feed into our latent variable models, we can ensure that they are not duplicates.
Yeah, actually, that's just a tangent or close related to our last topic by speaker last week, Justin Esnery, talk about, he studied corruptions and tried to tap into the dimensionality of different measures and try to find out which one is was actually measuring as another dimension that could have been missed by most studies, and thinking corruption should be one dimension, or maybe one factor versus 2 factor. So that I think your research is the first one to do something. I think you said you're going to do next is that treating this as a latent variable, and because Kevin pointed out that then aggregation is one issue, the other one is generating measurement from and how these variables are measured, reported, or treated. But that is a latent process, and we do not apparently or from the surface and we can see, oh, this is what is reported, but that was not a lot other latent construct is not recorded or not reported or not measured and not taken for granted. This is not there. And I think your next project will be important, and because you're taking it as a lane one, and then try to see what has not been reported or what has been missed, and but we take for granted that that is not in existence. So and I think I really look forward to that. And tell us a little bit more what you plan to do. And in this sounds like a difficult project, though. Yeah.
Yeah, so I think that's where the next part is going to be very important here. And so
Yeah.
what we'll ultimately be doing is working at the beginning to kind of come up with alternative measures of intensity of how good or bad is it within these units of analysis. But yeah, the latent variable model one is theoretically one that has been developed by my co-authors, and ultimately, you know, it's the idea that more generally students here can think about the biases in data generating processes. So take human rights reports. We know that actually the reporting institutionally has changed over time, and that there's actually a bias whereby we have now more violations than ever before, because we not only just have more data, we have social media, we have newspaper reports, we have more open countries. So the opportunity to observe repression now is more likely today than before. We also have more categories of rights. For the example of torture, solitary confinement was never included at the beginning, but now it is. And so we see categories expand. So we have more data than before. And these are the sorts of things that we'll include in our models, accounting for those types of biases in the data generating process. And we've not even spoken about some of the reporting biases across reports. How's Amnesty International different to Human Rights Watch, to the US State Department? And then obviously when we get to the subnational aspect, there's going to be biases geographically as well. But yes, so we're presenting this next step with the dynamic latent variable model at Peace Science next week. And I think this is going to be really interesting to show how that works there.
Yeah. Great. Interesting. Peter, do you have questions from your students or from your side?
Oh, I can't hear you.
Maybe I will take the opportunity to ask one more question. I have many questions then. So, Rebecca, you have a really strong record of productivity, and can you teach our students, including myself, how to? You have a very strong team too, and you have lots of great ideas. So, give us a little bit more inspiration how you plan and organize your research. And you have a lot of projects too, and also you have a lot of pre-registered projects. And maybe you can use this opportunity to teach our students and how you organize and plan the research, particularly working with your co-author team.
Yeah, definitely. So I think that there's a couple of dynamics that work for me, perhaps. And I'd say the first one is you have to be passionate and interested in what you're researching, because you're going to be dedicating a lot of time to this. So pick topics that interest you. And for me, certainly, I've always been interested in problems, you know, measurement problems, or uncovering something new about a topic that we don't know necessarily. And so I would say not necessarily shying away from difficult topics or topics that may not necessarily be mainstream yet. But, you know, these days I have some solo authored projects as well as co-authored projects, and so I think working in a team is something that all students should try and get experience in. And I think something that students can actually start doing is working with each other and or co-authoring with each other. And these are skills that even if you don't go into academia can be really good for non-academic. But also the data science skills are absolutely very attractive right now to lots of different employers. But as far as, you know, general research productivity goes, I think, you know, you have to be incredibly disciplined. Obviously, as a professor, you have to really do 3 jobs: service, teaching and research. And so it can be quite challenging, but it's trying to multitask and separate your time. And one of my colleagues, Dan Arce, he gave a book to me and to many of us junior colleagues called Deep Work. And this is a book that you could read, which is all about how we live right now in an incredibly distracting world. And skills like research absolutely need high level thinking, need time to not be distracted, thinking deeply. And so structuring your time is something that's just really important, and making sure that you can have periods of focus that are undistracted from email, from our phones and so on. But yeah, I think that I've kind of planned my research agenda in terms of thinking like long-term longevity, and so trying to always have projects at like an early stage, a middle stage, an under review stage, so that it kind of all keeps flowing and from one to the other. But I've really enjoyed working with my colleagues on these interesting projects, and I think it's from going to conferences and presenting research and workshops and talking to people and, you know, networking, and it's those where collaborations have just naturally been built, because I'm interested in this, so are you, and let's work together. But you mentioned briefly the pre-registration aspects, and so I think just like how I went on a bit about validation, how important validation is in text analysis, in public opinion research, I do some survey experiments on human rights. Pre-registration is really important. So having that checks and balances at the beginning, pre-registering your hypotheses, outlining your research design, and it can be really useful for actually users and researchers to learn the research design process when you changed, when you made decisions that went a different way. And I think just being transparent and making your research reproducible is something important too.
Great. This is a really great tips, and for not just for students, for myself too. And all right. And okay. Do we have more questions from Taiwan side or from the US side? And I found the book called Deep Work now. The title is let's see. The full title is Deep Work and Rules for Focused Success in a Distracted World. And particularly applicable to me too, and so easy, so prone to distraction, I think, and not just for students, for faculty, and we are easily distracted by multiple things, and yeah. All right. Do we have more questions? And otherwise I can ask questions the whole night. I have so many questions for Dr. Cordell. Yeah, Peter.
Yeah. Here's a couple of questions. Following the public opinion questions, because some of our students, they're working on this project like that, and then they're asking if you mentioned about the pattern questions, right? As not as complicated as those. You have to have a correct notion of each words. So the pattern question, can you give us some more examples about that in terms of we survey the news or from the public opinions? Yeah. Gives a little bit more examples of how you define or come up with the research questions about asking patterns.
Sure. Yeah. So for those of you that are interested in public opinion, so you can actually use text as data approaches on survey data. So think of, as an example, for say you run a survey and you have a question that asks open-ended response questions, like maybe it says a question, what are the top 5 issues that are important to your country right now? Or what are the top issues that are most important in this election? And maybe someone says it's the education system, someone else says it's the immigration system, it's national security. And you can actually use text analysis to analyze structural topic models to analyze those open-ended responses, because some people may take lines and lines and lines, and it'd be very difficult to go through and classify and code and read every one of those responses. And so text as data approaches like structural topic model could be actually used to analyze those reports after. But in terms of public opinion and text as data, so I can give you another example from a student in my class. So she is interested in whether or not public opinion on the European Court of Justice changed in the UK before and after Brexit. So, you know, that's a question that ideally you would have a survey out there before asking the same question, a survey out there after Brexit, and you could compare the results, but we can't turn back time and we don't live in that world. So what she's doing is she's used the API at the BBC, which is really one of the main news sources in the UK, and has downloaded all newspaper articles that are about the European Court of Justice the year before Brexit and the year after. And she's coming up with a theory about if the number of times the European Court of Justice was mentioned in newspaper reports on the BBC, if it went up after, that showed that actually interest in public opinion went up after. If it went down after Brexit. And so that kind of gives us an idea of public opinion data that could be used using text as data. And she's going to validate it by looking at Google Trends data and seeing whether the searches into Google in the UK before and after Brexit about the European Court of Justice, do those patterns and trends match onto the newspaper data that she's collecting, the text as data? Because maybe there's differences between elite reporting in the news of, say, the European Court of Justice before and after Brexit, and ordinary people just on their computers typing what is the European Court of Justice or other issues related to that. But in general, identifying patterns and trends, I think that it's a comparative question. And so one thing I encourage my students a lot to do is, what's the comparison? What's the variation you're interested in? So, you know, you could pick 2 topics, like maybe you're interested in looking at whether members of parliament in the UK are debating immigration issues differently if they're a member of the Conservative Party or the Labour Party. Or you could just look at the speeches, look at what they're saying, because that potentially tells us something about their preferences and political party behaviours. And you could just do simple word counts. So I think coming up with patterns and trends is maybe just comparing, either having like 2 groups to compare, 2 countries, 2 topics. Certainly with text analysis, it can be the co-occurrence of topics. So does Labour Party on the left in the UK, do they talk more about immigration as it pertains to education or housing? And does the Conservative government talk about it more when it relates to, say, the economy and the public health system or something like that? And so, you know, practically it can actually just be word counts, and it can actually just be t-tests and correlations.
All right. Do we have more questions for Professor Cordell? All right, I think while we are looking through the chat box, if there's more questions, and yeah, for your information, is it okay I can share your website to the
Of
students
course.
now, so I can point you to Professor Cordell's research. And actually, this is a very easy website. It's just called www.rebeccacordell.com. So I'm going to type it in the chat box. And she's very organized to get things under in her CV and also research teaching. And yeah, this will be some I think great resources for resourceful page for students. And also I sent the page called SNARP and snarpdata.org. So that is a link also I sent earlier, and you can check into their work here, and also some of the papers or some of the pre-registered projects, and just to take a glimpse at what they have done, and also what they are planning to do. I also I got that too, and then I got it earlier, and by Justin Kramer's book, text as data. Is this your textbook used in your class?
Yes, that is the one I'm using in my class at the moment. Yeah.
That's great. Yep. Yeah, great. So I really hope you can frequently, regularly order the course. So because I told my students, I think this is it should be a core course or required course for every student, every data science student to take. And now because I think data is really the trend, and not that it will replace the traditional survey data or other experimental approach, but we are getting more and more easier access to big data, text, or web data from the internet. So that is opening a new window, or bring us to a new world of data possibility and also model possibilities. And now we have ChatGPT language model approaches. So this will be great. And yeah, I look forward to I hope I can take a course too. Actually, I want to learn from you and more, and the latest methods too. All right, then at this point, do I have more questions from Taiwan or from the US side? All right, I think I would just have invite everyone to give a round of applause to Professor Cordell. We can use the re-ed here, and there's something called applause, or you can actually applause with sound. Okay, thank you very much, Professor Cordell, and I hope you have a great rest of the semester, and please keep the course coming every year. So I believe that more and more students need to take that course. Yeah.
Great. Thanks so much for inviting me.
Indeed, and the pleasure all ours. All right. Thank you, Dr. Cordell.
Take care. Bye.
Yeah,
Bye. Have a good night. Yeah, good night.
Yeah, bye.
All right. And before I go, I want to remind our students, and next week we will take a break, and our next talk, which is the finale, will be by Dr. Ryan Kennedy and University of Houston. And Dr. Kennedy has multiple projects, but I chose this project. It's called the Legal Professionals attitude toward algorithmic and human decision making. I think he more explicitly compare machine or computational decision making process versus the human only decision making process. He's proposing new ways of understanding AI, or generally synthetic AI. So using judicial models and judicial data would be a great illustration. All right, and that will be November 17 in Taiwan, November 16 in US. Please do go to our website to register, and also our recorded videos will be on our channel, and you can go to YouTube and look for Data Analytics Colloquium, one word, so you can get access to all our videos. All right.
Okay. Thank you.
Do you have any remarks, concluding remarks, Dr. Pan?
Well, I think I just want to just a reminder, okay? This
Yeah.
machine learning or AI or those data, I mean, there's data sciences. It's really applying to. It's good to apply it to our social sciences areas. So I think this trend is unstoppable, and again, more and more
Mhm.
people are using these techniques or methods to do
Mhm.
research. So I encourage my students try to explore themselves into this kind of topics and the methods. I think just like Rebecca just said, it's not necessarily we have to use it for writing papers. As long as we have those techniques or skills, and then it might be a very it's a plus, always a plus when
Yes.
we're looking for a
Mhm.
job on the job
Mhm.
market. I think so. I encourage my students to explore themselves into this area. Yeah, that's just a
All
comment.
right. Yeah,
Mm-hmm.
indeed. And I hope you
Thanks.
enjoy our talks,
Mhm.
and also our channels will be resourceful to you. All right, then I want to say bye, and look forward to seeing you in 2 weeks.
Yep.
All
I'll
right.
see you 2 weeks from
Bye.
now. Goodbye.
Yep.
Thank you,
Okay.
Dr. Carl.
Bye. Bye.
Bye.